Hi there and welcome to our latest edition of our P4 Radiation for Life topic. Now today what we're going to be looking at is safe electricals and how we can protect our appliances and ourselves when we're looking at electrical items. Anyway, I shall see you at the end. Bye bye. Okay, so we're going to be looking at electrical safety today, or how we can make electrical items safe. So here are our objectives for today. By the end of this lesson you should understand how resistance of a circuit can be calculated, and there's a mathematical equation for that. We're also going to look at how electrical appliances are kept safe by fuses, circuit breakers, earthing and double insulation. Okay, so first we're going to look at what a circuit is. Now this should be a recap of what you have done previously. Now a circuit is where we have a full connection of wires or appliances that allow electrons to flow. Now if you just connect up a whole load of wires, it's not going to be a full circuit. You need to have that push, and how we can do that is we can add a power supply to it like this. So we've got a battery which will push electrons around. Okay, we can then put in a light bulb here, and that will then use that electrical energy. So we've got the push of the electrons round, and then that energy is transferred to light energy at the light bulb, but the electrons will carry on flowing around. Now if we look here at the light bulb, this is what we call a fixed resistor. Now a fixed resistor means that it will provide that resistance to the electrons. It will slow them down, stop them from moving as much in a fixed way, so the value will always remain the same. Okay, now this is the symbol for a light bulb. Now a variable resistor in a circuit will look something like this. That's a resistor, and then a variable resistor will have a line going through this. Now you may have one of these at home as your light switch. So if you've got a dimmer switch where you can turn it up and down, it will go up and down, so it turn the light up and down. So you've got the variable resistor being the light switch where you're moving it, turning it, and then you've got the fixed resistor which will be the light bulb. Now these variable resistors are sometimes known as a rheostat. Okay, so voltage, current and resistance are all related. Now you can look at the mathematical term here, where resistance is equal to voltage divided by current, and we can put this into a triangle. Not that shape, not that one. Let's delete that. Right, there we go, that's the right one. Okay, so we could put that into a triangle, and we can draw a line at the top and a line coming down the middle, and we can put our terms into here. So we've got voltage, we've got resistance, and we've got current. Now current is given the symbol I, as the symbol C is used for charge. Now in terms of our units, we measure voltage in volts, which is a V. We measure currents in amps, and we measure resistance in ohms, which is given the Greek letter omega. Now if we put our equation back at the top, and we can have a look at a example here. Okay, now we've got our circuit, so we've got our battery here, we've got our ammeter here, we've got our light bulb here, and then we've got our voltmeter here. Now we can see that the voltage is 3 volts here, the current is 0.2 amps here, which gives us a value of 15 ohms as the current. Okay, now you do need to be able to do that, but don't worry too much because this equation will be given to you at the front of the paper. Okay, so we're going to have a look at wiring a plug. Now, I feel this is a little bit redundant now, as most plugs that you can buy, or most electrical items that you buy, have a sealed-in plug. But we'll go through this anyway. Now, you've got your plug here. Now, what happens is the electricity comes in through here. Now you can see here that you've got a metal connector. Okay, that you've got a very fine wire that goes to this metal connector here. Now behind here you've got the pin that goes comes from the electricity. So you've got the electricity coming in through the wall, up through here, and then in to the live wire to the appliance. Okay, now back from the appliance you've got the neutral wire that completes that circuit. So you've got in through the brown, out through the blue. Okay, so that's how your normal circuit runs into your electrical appliance. Now it comes in here at about 250 volts, which is what the reading will say on the plug, and then it will go out through the blue wire. So why do we have this wire here? Now the green and yellow is the earth wire, and what that will do is it's a safety feature which will carry any excess charge away from the electrical appliance. Okay, so we're going to look at fuses and circuit breakers. Now what both of these do is they break a circuit. Now a circuit breaker will do it in a way that it can be reset. Now what it does is it causes an increase in current going into the item. The increased current will cause an electromagnet to move and break the circuit. The good thing about that is it can be reset. Now with a fuse, if we look at our diagram again, we've got the electricity coming in through this first pin, and in here you have a very small piece of wire with a very low melting point. Now what this will do is if you have an increase in current, it will break the wire, it will melt the wire so that you don't get any electricity coming through, so it'll break that circuit. It's important for doing that because it will prevent the appliance getting over hot or overheated. It will also stop it becoming more charged than it needs to be, which will help protect the appliance and protect the user. So how do we decide what type of fuse to use? Now power is equal to voltage times current. As we can see from this equation. Okay, now we can put this into a triangle. Here, so we've got power at the top and voltage and current. We measure power in watts, current in amps, and voltage in volts. Now to work out the current, we cover up the current, which means we've got power divided by voltage. So current is equal to power divided by voltage. Now if we have a power of an item of 500 watts, we can do 500 divided by 230, which is the voltage in most UK appliances, and that will give us a value of 2.2 amps. Now what we then need to do is we need to round it up. Okay, we don't round it down, we round it up to 3, so we'll need a 3 amp fuse for this particular appliance. Okay, so how does earthing work? Now if we take an electrical appliance here, now if this becomes faulty, so for example we've got this outer metal here, if that becomes live because of a faulty live wire, we get a build-up of electrons here. Now that can cause problems for the appliance, stopping it from working, or it could cause problems to the user. Now because we've got this, we've got a change in the whole circuit. Now what we'll try to do is try to move that circuit to the area where there's lowest resistance, and this will be through the earth wire. So the earth wire will take this away and it will recreate that circuit and cause the trip switch or circuit breaker or the fuse to melt, breaking the circuit, so it's all protected. Okay, so the last way is by double insulating, and this does exactly what it says on the tin. Now this is where you get a double insulated material, so you've got the insulation around the wires, and then the actual metal inside the equipment is insulated as well. So for example a hairdryer or an electric shaver, so you don't need to have the earth wire. Now to tell if something is double insulated, you normally have a symbol that looks like this, and that just shows that it is double insulated. Okay, so you don't need the earth wire, so you could only have two electrical pins. Okay, so we've looked at a couple of equations. We've looked at how we can calculate resistance and how we can calculate the current using the power equation. And it's a good thing to remember the triangles for both of those. We've also looked at how we can look at circuits with fixed and variable resistors in them. We've also looked at how to wire a plug and what the role of a fuse and a circuit breaker is, and we also had a look at earthing and double insulation as well. Anyway, I hope you've enjoyed this video, and I will see you next time. Bye bye.